Well, hello, geometers and seekers of general truths. Let us talk about a new topic today in transformations, which is rotation. So we've talked before in this unit about moving things and reflecting things, and now let's talk about rotations. Okay, so I've got some definitions up here, but before we go to the definition, actually, let's go down and do an example together, and then we can revisit that example and this definition. Okay, so we have this problem here. Rotate, okay, so what we want to do here is rotate point P 40 degrees around point Q. Okay, so rotate P 40 degrees around point Q. So Q here is going to be known as the center of rotation. Okay, so Q here is the center, and P is the thing that we're rotating around. So we need to take this point P and spin it somehow. Well, and spin it at a length or a angle of 40 degrees. Now, the immediate question is, well, which direction do we rotate? Do we go towards the left here or towards the right here? Well, let's go with some specific guidelines here. When an angle of rotation is positive, that means it's done counterclockwise. Counterclockwise, I'll abbreviate. So, when an angle of rotation is negative, it is done clockwise. Okay. So in this case, we have positive 40, so we're going to go counterclockwise. Okay. And I'll illustrate the steps here. So the first thing that we're going to do is take a line segment between P and Q like so, and then make a circle using that line segment. Right? So set our compass to this size and make a circle, or at least a part of a circle. And this tells us that P prime is going to be somewhere on this arc. Okay. Now where exactly? Well, it's in such a way that it produces a 40-degree angle here with the point Q. So P prime would appear right there. Okay. Now I did that very sloppily and I did that very inaccurately, so I want to do it again in using some software so that we can see it more perfectly. Okay, so I've got GeoGebra up here, and it's a nice software that will do constructions perfectly for me. So I'm going to repeat the process. I have P and Q, and the first thing I'm going to do is make a line segment between P and Q. Right? And then I'm going to use that line segment as the radius of a circle. All right, so just like so. So I have a circle here, and this tells me that P prime is going to be somewhere on this circle. Okay. So for example, if the angle of rotation was 360 degrees, then P prime would be back to in the same location as P. But where is it exactly? Well, we are going to go counterclockwise. So I'm going to use my angle tool here. And if you didn't have software, we would just do this with a protractor. So we're going to go 40 degrees counterclockwise. And there it is. That's where P prime would appear. Right? And, you know, a few things here that a few things here that I want to point out. First, if we were to make this line segment from Q to P prime, those two line segments would in fact be congruent to each other. All right, so back to this picture here, we can say with certainty that P to Q and P prime to Q would be exactly congruent to each other. Okay, so this is what it means to rotate a point, and you can see in some other examples that when we rotate in a point or an angle or an entire picture, it follows sort of the same rules. Okay. So let's look up now back at the definition. A rotation is a transformation in which a figure is turned, okay, or spun. Okay, that's effectively what rotate means, about a fixed point. Okay, so in our example, Q is the fixed point. Okay. Q is that fixed point has a special name. It's called the center, or the center of rotation. Okay. And the angle of rotation is formed by rays drawn from the center of the point to its image. Okay, so exactly like so here. So this angle of rotation, 40 degrees, is formed by the rays or the line segments from the center to the point, and from the center to the image of the point. All right, so that we have a brief introduction into what it means to make a rotation, or to the precise definition of rotation in geometry. We're going to end this video here and start another one on rotating figures in a coordinate plane.